Hello everyone, so today I'll be solving this problem. So this is number of ways to divide a long corridor. Okay, so the problem states that along a long corridor there is a line of seats and decorative plants. You are given a zero index string corridor of length n consisting of letters S and P, where S represents seat, P represents a plant. One room divider has already been installed to the left of index 0 and another to the right of index n minus 1. Okay, so basically we have you can say some walls are there, or here they have mentioned it as dividers, but let's consider these are walls. Okay, so yeah, and between that there are some S and P's denoted here. Okay, cool. Now additional room dividers can be installed for each room indices between I minus 1 and I. At most one divider can be installed. Okay, divide the corridor into non-overlapping sections where each section has exactly 2 seats with any number of plants. There may be multiple ways to perform the division. 2 ways are different if there is a position with a room divider installed in the first way but not in the second way. Okay, now the finally we just have to okay, that was a long question. Okay, but yeah, the question finally says that the number of ways to divide the corridor. Since the answer can be very large, we have to return the mod answer with 10 to the power 9 plus 7. Okay, and if there is no other way, we have to return 0. Okay, so yeah, so that's the problem statement, and it's a pretty big problem statement. But yeah, so let's see how to solve it. Okay, so here in this example, so okay, basically what's the idea? So the idea is we have to divide this string, okay, into some segments. Okay, so we have to divide this let's yeah, this string, okay, which they are referring to as corridor, okay, into some segments such that, okay, into segments, okay, uh, such that each segment, okay, contains exactly 2 seats. Okay, so yeah, that's the first idea. We have to uh, basically partition the string, okay, into segments such that uh, in every segment we will have exactly 2 seats. Okay, now from here, um, we can think of a test case. Okay, what about, let's say we have been given a string like this. Okay, so can we have a segment, or can we partition this string such that segments will have 2 seats at least, or like not at least, exactly 2 seats? Let's see. So if I have this, okay, if I partition it from here, okay, now this guy is only one. Okay, so this is not a good partition, right? Cool. Now let's say if I partition it from here, okay, now this segment has 2 seats, which is good. It's like satisfying our condition. Okay, but what about the rest? Okay, now we are left with only 1 seat, which basically means we cannot partition this string. Okay, so here the answer will be 0. Okay, cool. So here also if you see, okay, let's take this guy only. So I have a S, I have a plant here, I have 2 seats here, then I have a plant, then I have 3 seats here, then I again have a plant. Okay, cool. So let's start from this. Okay, so from here if we look, okay, I have 1 seat, I have 2 seat. Okay, so I have a segment here. Okay, all good. Okay, then I have a plant. Okay, so what I can do is I can either like stay with this, or I can extend this segment to this. Okay, because this segment and this segment, okay, both are having only 2 seats. Okay, and that is satisfying our condition. Okay, so I can do this or I can extend it. Okay, let's say I extend it. Okay, then then my pointer will start from here. Okay, from here I will again look for another seat. Okay, so now just next to it I again have 2 seats. Okay, but here also after this I have a plant. Okay, which basically means I can choose like this segment, or I can extend it. Okay. Similarly, if we would have stick with this segment, okay, then for this guy, okay, or this segment, let's do this, okay, for this segment I could have extended it like this, okay, or I could have extended like this, or I could have extended it like this, okay. So the idea that comes to your mind is my plants between my segments, okay, are kind of increasing the number of ways in which I can partition it, okay. So basically whenever I have a p here, okay, that's the you can say that's the entity which is increasing my number of ways, my number of ways, okay, cool. Now again, let's say I took this guy, okay, then I have this guy, okay, then from here if I extend it to this, okay, I again have two seats, which is good, then I should stop, okay, because I already got two seats, okay. Then here also I have choices, okay. Let's say in the past, if this guy was stick to like this segment, okay, I could have used this p to either extend this segment, okay, or if this guy was like this segment, okay, then for this guy I would have stick to this only, okay. Then let's see, now after this I have a single s, okay. From here if I start looking for another seat, nope, there is no other seat, okay. So from this we can have an idea is like we basically need to uh, divide our segments, okay. And whenever we have two seats in a segment, we should start looking for other segments where there are two seats again, okay. So yeah, that's the second case, okay. So let's take another example, okay. Let's say I have ss p, okay, then pps, then I have, let's say, ps, and let's say I have three p's here, okay, and finally let's say I have 2s, okay. Now let's see how we can do it, okay. So from here we can see that, okay, when I have this segment, okay, so first let's see, okay, let's connect a starting s with an ending s, because we know like there are only two seats required, okay. So let's simply pick up the initial s of a segment and the ending s of a segment, okay. So this is one, okay. Then again we have this thing, okay, and this guy, okay. So in this segment this s is starting, and then in the same segment this s is my ending s, okay. Then finally I have this segment, okay. For now I'm just ignoring p's, okay. So see, here I have a p, okay. Why I have taken this p in this segment? Because this segment is not yet completed. Once I find this s, now in this segment the s count becomes 2, okay. And now this segment is fulfilling my criteria, which is like each segment should have at least 2 seats, okay. That's why I have divided, okay. Now I have, if I look at the segments now, okay, let's give some indices to them, okay. It is 0 1 2 3 4 5 6, I have 7 8 9, then 10, then 11, okay, cool. Now these are my segments. Let's say I store them, okay. So this guy is like what, 0 to 1 is one of the segment, okay, like it's a complete segment, there are two seats, okay. Now 4 to 6 is another segment, okay. Then 10 to 11 is another segment, okay. Now these are the segments where I know like my I have a starting s and I have an ending s, okay, and there are only two s's, okay. Now in between them if I look at the distances, okay, so distances between these segments, okay. Now here the distance is 3, okay. Now from here to here, the distance is 4. Okay. Now if I look at this guy, okay. So if I look here, okay, I have multiple choices for this segment. Okay, I can either stick to this, or I can extend this to this. Okay, or I can extend this to this for this segment. Okay, so that means the number of p's or the distance between my segments. Okay, so this distance is basically denoting what? This distance is basically denoting the number of p's present between those segments minus 1. Okay, because you can see the distance is 3, and here I have 2 p's. Okay, cool. Now what we observed here is the p is the entity which is increasing my number of ways. Okay, that means if I simply calculate, okay, if I simply calculate the distance between them, okay, and I do the multiplication of those distances, okay, that will automatically give me the answer. Okay, why? Because for every p, okay, like for this example, let's say SSP SPS. Okay, I have a complete segment here, I have a complete segment here. Okay, so this p can be shared between this guy, okay, and can be shared within this guy. Okay, like if this guy hasn't taken this p, okay, then what that mean is I have two partition places here. I can either partition from here, or I can either partition from here. Okay, similarly, let's say here I have some let's say kp's. Okay, let's say there are some kp's here. Okay, that means I can either partition from here, I can either partition from here, let's say for this guy. Okay, here, here, here. Okay, so there will be k plus 1 uh, like ways to extend my segments. Okay, I can either stick to not taking any p, okay, or I can extend this segment by taking a p. Okay, or then I can extend it to like taking 2 p's, like that. Okay, now if there are k p's, which means I have k plus 1 ways to extend this. Okay, cool. Now if I have let's say some kind of this kind of a thing. Okay, let's say there are some k1 p's here. Okay, then again let's say I have some, let's take another example. Okay, I have again a complete segment here. Let's say here I have some k2 p's. Okay, and finally let's say it's ending with ss. Okay, and yeah, so what I'm looking here is, so the number of ways I can extend this segment. Okay, so that will increase the count, as well as this segment of p's here will also contribute in either extending this guy, okay, or either extending this. Okay, so the count of p's in between my segments, okay, if I simply do a multiplication of them, okay, that will basically give me the total number of ways. Of ways. So yeah, that's the idea. Okay, once you have found the complete segments, so here the definition of complete segments is, so a segment uh, starting with s, okay, and ending with s only. Okay, so once we find out the complete segments, okay, then we can simply calculate what is the distance between those segments, and those distances will basically give me the number of partition count. Okay, so what we looked at here only. Okay, so yeah, so and once I have found out the distances between them, I can simply do a mod of those distances. okay, like a product of those distances, and finally my answer will be uh, a product of those distances mod. This will give me my answer. Okay, so it's a basically a permutation kind of a problem. Okay, because I have k1 choices here to extend this, I have k2 choices here to either extend this. Okay, so I simply need to do a multiplication here. Cool. So that's the simple idea. Now, how to code it? Okay, so a naive way will be first, uh, let's say, store your segment starting and ending indices like this. Okay, now from this you can calculate the distances. Okay, so these are my distances, and finally do the product of those distances. Okay, and do the mod. Okay, that will give you an answer. Okay, but we can solve it using without using a auxiliary space here. Okay, a simple for loop will work. Okay, so I think it's better if I show you how to code it. Okay, from that you guys will understand, like, okay, how we can do it in a single pass without using any auxiliary space. Cool. So I'll be coding in Rust. Okay, then later on I will show you the same code in C++ and Golang. Cool. So first thing first, so in Rust I don't need to consider corridor as string, I will consider it as bytes. So I'll create a bytes array. Okay, so I'll say corridor as bytes. Okay, then so why bytes? Because like, if you guys have question like why I'm converting to bytes, because string indexing in Rust is taking takes linear time. Okay, so but if we convert it into bytes, so it will behave like a array, like in C++, Python, or Golang, any other language. So yeah, that's why I'm converting to bytes. Cool. Now let's find the length of my corridor. Okay, so that will be bytes of length. Then what I will do, I will initialize my answer. So answer as I will initialize at 1. Okay, because I need to do multiplication, I cannot initialize as 0, otherwise my whole product will become 0. Okay, then I will initialize the mod, so which is this with this and a 7. Okay, cool. So my answer and modulus have been derived. Okay, now cool. Now I will iterate over my corridor. Okay, so I'll say for I in range n. Okay, now I'll check if bytes of I. Okay, if I'm encountering a s here. Okay, okay, if my current character is s, what I will do is I will have a counter to count the number of s's I have gotten so far. Okay, so I'll call it s count 0. Okay, I will increment s count plus equal to 1. Okay, then so so as we saw here, okay, we keep on finding out our complete segments here. Okay, but once we fell here, okay, in this case, okay, here for this s there is no ending s. Okay, which means I cannot partition, which means I cannot partition this array at all. Okay, where every segment will have 2 seeds. Okay, so in that case what I can do is so finally, okay, I'll show you like how I will deal with that case. So yeah, so I will increment this. Okay, then I will say if s count is equal to 1. Okay, and what I will do is, so I will be doing the same thing. Okay, but I will not be using this auxiliary array. What I will be storing is, once I have found a complete segment, I basically need this index. Okay, to be differentiated, or like to be subtracted from this index, so that I can get the distance. Okay, so yeah, so I'll be storing I will create a variable to store the last segment's end index. Okay, so I'll say, let's say last s index, I will initialize to -1. Okay, now what I will say is if s count equal to 1, okay, and my last s index is more than 0. Okay, then yeah, I will calculate the number of or the number of ways I can partition or I can extend the older segment. Okay, so I'll say let dist equal to this will be my current index I minus last s index. Okay, and yeah, and finally I will say ans times this dist. Okay, mod. Cool. And my answer is in 64. This guy also needs to be in 64. Okay, and so which means this thing also needs to be in 64. Okay, cool. So what I'm doing here is, so basically here, okay, so or maybe I can stick to this thing. Okay, so when I am initially doing it, okay, I'm saying, okay, here once I found this guy, here s count will be 1. Okay, cool. Now if I am looking at my last s index, okay, this will be -1, right, as I'm initializing. Now if my s count is 1 and let's say my last s index is -1, that means I haven't got a complete segment in my past. Okay, cool. So after this, okay, if I keep on iterating, okay, here my s count will become 2. Okay, cool. Now after this, let's say I will keep on incrementing my pointer. Okay, and I will arrive at here. Okay, so I think I will first show you how I'll be doing it. So if s count equal to 1, last index is more than 0. Okay, I'll say this. Now what I will be doing is, let's say I have found my complete index. Okay, let's say my s count becomes 2. Okay, that means I have found a segment, a complete segment. So at that time I will update my s index to my current index. Okay, and I will again restart calculating my s count. Okay, cool. Now how this will help me is, now in this part, okay, once I have found the complete segment, okay, when my s count becomes 2, now at this time I'll be updating my last index count to this index. Okay, let's call it 1. Okay, 1. Okay, now this guy, now again I'm restarting my s count, right, which basically means when I will be arriving at this index, okay, I'll be incrementing my s count. Okay, and at that time I can change, I can check when my s count becomes 1. Okay, that means now I have the power to look at back whether I have gotten any complete segment. Okay, so if my s index is more than 0, that means I have gotten a complete index or like a complete segment. Okay, then I can use the last s index, okay, which is this guy, okay, to be subtracted with my current index, okay, which will be located at what, 1 plus k1. Okay, here like in between them there were k1 p's, right? So yeah, this guy will be located at 1 plus k1 index. Okay, and this will be 0. Okay, now if I subtract them, okay, this will basically give me k1. Okay, cool. Now this yeah, now this will give me basically k1. So if there are k1 p's, okay, their subtraction will give me k1 plus 1. Okay, which is indirectly the number of ways I can partition, right? So like we saw here, okay, if I have k p's, okay, I can, so I have the power to not take any piece. Okay, simply take the segment as it is. Okay, and so that's why this first segment is for the 1. Okay, now if I am keep on taking piece or I'm extending this segment, okay, now I have k choices to do that. Okay, so yeah, when I'm subtracting here, okay, as we saw here, right, so my s was located at 4. Okay, but the last s index was 1. Okay, when I'm subtracting, it is giving me 3. Okay, which is the number of p's in between them -1. Okay, I need this number in my final product count. Okay, so their subtraction is directly giving me the number of parts. Okay, I think this distance I can simply say num partitions. Okay, uh, cool. And so yeah, Once I have found out the number of partition, I will be multiplying with my answer and I will be doing a modulo. Okay, and yeah, and finally what I will be checking is if s count is not like is not equal to 2. Okay, here what I'm doing is after 2 I'm resetting it, so I will can check if s count is not equal to 0, which means s is, let's say, 1. Okay, then that means I have a s which is looking for a partner. Okay, so I haven't been able to partition my string. Okay, so in that case I can simply return 0. Okay, otherwise what I will be doing is I will return my ans as I32. Okay, cool. Now here another case will be, let's say I have a string which is filled with p's. Okay, then that means my s count will always become 0. Okay, so yeah, my s count will always become 0, and I won't be able to partition it. Okay, so this is another edge case. Okay, so yeah, but if you look at here, okay, if s count is 0, okay, which basically means I'll be returning my answer. Okay, but um, my answer uh, will be 1 here because I'm initializing with 1. Okay, then I need another flag to check whether I have found any s in my string. Okay, so I can create a boolean variable. So let mut I can say has s. I'll initialize to false. Okay, and here I'll say once I have found s, that means this guy will become true. Okay, cool. Now here I can say, okay, if s count is still non-zero, okay, which basically means s count is 1, then I have a guy which is looking for his partner. Okay, so in that case I cannot partition, I will return 0. Okay, another case will be if has s is false. Okay, which basically means uh, my entire string is filled with p. Okay, so in that way I cannot partition, right, because there is only p, so I cannot do any partition to get at least 2 seats in a segment. Okay, so in that case I will return 0. Okay, cool. I will run this code for all test cases, and yeah, I failed because I have forgotten this in word. Okay, cool. And I think one more thing I'll be requiring, this I is u size, last index is also, yeah, last index is -1. Okay, which basically means it will panic because because it is doing a subtraction with I, which is u size. So I need to either convert this guy, so I can explicitly say this is I32, but once I said this I32, this will be u size, so I cannot do a u size minus I32. So what I can do is I can create another variable. Let's call it current index. I'll say I as I32. Okay, and instead of using I can use current index. Okay, now let's run it for all test cases. Okay, oh, there is a R here. Okay, now let's run. Whew, again an error. Okay, yeah, so this thing need to be I32. Finally, okay, cool. All test case passed. Now let's submit. And voila, it passed. Okay, so yeah, that's the idea. So keep on looking for complete segments. Okay, once you have found out all your complete segments, in between them just calculate how many number of p's are between your complete segments. Okay, now the number of p plus 1 will give you the number of ways you can extend your segments. Okay, and yeah, once you have found out every p's, okay, in your complete segments, okay, like between your complete segments, simply do a product of them. Okay, and yeah, keep on multiplying them, and that will give your answer. Okay, so a couple of edge cases, like when s count is not equal to 0, which basically means you have a s, okay, or you have an odd number of s, so in that case you cannot partition it. Okay, and other case will be when there are no s's, only plants are there. Okay, so in that case we cannot return any answer, we will simply return 0. Otherwise we will return our answer. Cool. So yeah, it passed for Rust. Okay, so what I will do is I will show you the code for C++. So yeah, in C++, the code is pretty identical to Rust. Okay, so here similarly, I have initialized my n, the number of characters in my string, then the modulus value. Okay, so what I have done here is, okay, so here I was checking whether there are s's or not. Okay, so basically I'm saying that okay, there are no s, I'm initializing to true. Okay, but once I have found s, I was inversing my flag to false. Okay, now yeah, here the iterations are pretty identical. So once I found the current character is s, okay, I was incrementing my s count. Okay, now whenever my s count has become 1, then I'm checking whether in the past I have looked at a complete segment. Okay, so that check is using the last s index. And once I know, okay, I have a complete segment in my past, then I'm simply calculating the distance between my current segment, okay, and my past segment, and I am incrementing my answer with the product. Okay, cool. And here in this edge case handling condition, I'm basically doing a inverse of this. Okay, like both are basically same. Okay, so here I'm checking whether s count has become 0, which means like my guy, okay, has gotten its partner. Okay, so if that's the case, then s count will become 2 in my last couple of lines, and s count will become 0. Okay, this is for that. Okay, if s count has become 0 and I and I have got an s here. Okay, no s basically means I have not gotten any s, but yeah, if that is false, okay, which basically means everything is good, I have ss and all my, and I have gotten complete segments. Okay, then I'm simply returning my answer. Okay, cool. So this was the C++ code. Okay, and finally let's look at Go. Okay, so the Go and C++ code are pretty similar. um, I'll just submit this so that I can do a side by side comparison. Okay, so yeah, so here my C++ code, and here I have Golang code. Okay, so yeah, the C++ and Golang code are pretty identical. So yeah, so here I'm initializing all the variables. Okay, in Golang also I'm initializing all the variables that I need. Okay, then yeah, I'm iterating over all the loop. Okay, then I'm doing the character by character matching, whether I'm checking like whether I have s. If I have s, then I'm incrementing my s count. Okay, and yeah, then I'm checking whether in the past I have a complete segment, and from that I'm calculating the distance between my complete segments, and once I have found that, I am updating my answer. The same logic that I have used in Rust and C++, same thing. Okay, then yeah, if s count has become 2, which means I have found a complete segment, then I'm updating my last s index. Okay, then yeah, then I'm resetting my s count. Okay, cool. Then yeah, this is the edge case handling, which is pretty identical to the C++ code. And yeah, this is my Golang code. Now let's do quickly do a time complexity analysis. Okay, so what I'm doing, all this initialization will be constant time. Okay, then I'm iterating over all the characters here. Now here I'm doing simple checks. Okay, like checking of variables which are all constant time operation. Then I can say this loop will take a big O of number of characters I have, right? Okay, now after this loop there is again this edge case handling check, which is also in constant time, and then I have this return statement. Okay, so yeah, my time complexity will be big O of number of characters there are in my corridor. Okay, now if I look at my space complexity, okay, I'm only using variables, right, and this is my input string only. Okay, and I'm not using any auxiliary space, which basically means my space complexity will be constant. Okay, so yeah, this is my time and space complexity. Cool. So that was the idea. Okay, so just keep on building your complete segments, and once you have found this, okay, just store the last index of your complete segment. Okay, and get the distance between your current segment, current starting segment. Okay, and the last segment. Okay, once you have found that found that, then that you can use to calculate the total permutations that you can get. So yeah, so I hope you learned something new. Okay, so if you like the solutions and the explanation, please do subscribe to the channel. Okay, that will motivate me to keep on doing this LeetCode. You can see like I have already 714 days of LeetCoding. Okay, so that will motivate me. Okay, if you guys comment or like my videos. Okay, and please, yeah, do subscribe to the channel. Okay, Cool. So that's all for the today's video. So just stay tuned to watch more videos. Bye bye.